What is up, everybody? Josh Tapp here again, and welcome back to The Lucky Titan. And today we're here with David, and I'm going to butcher his last name, Buniatyan. Was that good?
Nice job.
Yes, nailed it. Recently, I've had a really hard time pronouncing people's last names. So anyways, so David is one of the founders of Activeloop, and this has been such a really intriguing conversation for me, especially because this guy's story is so amazing. He was, as a Ph.D. student, ended up going over and being accepted by Y-Combinator, which many of you probably don't know this about me. I actually applied for Y-Combinator like 5 times. Didn't really have a good business idea, I'll be completely honest. Kind of laugh at it. I'm like, I wouldn't have invested in me either. Never got accepted to it.
I got there 4th time, so I also
you should keep
applying.
Dang it, I should have applied one more time, right? Anyway, so good stuff, right? So joining Y-Combinator, and they were able to take their company Activeloop, and they're really working in the machine learning space. And I was really intrigued by this. And this is one of the reasons I wanted to bring David on, is many of us, especially in the agency space, are looking to partner up with other companies like this or incorporate machine learning into our companies. So I'm excited to have David here to really dive into that with us. So first off, David, can you say what's up to everybody, and then we'll head in.
What's up, everybody? Thanks, Josh, for actually having me in the talk and your podcast. Really excited to be here and share any experience, knowledge, and information, insights with your audience. Happy to introduce myself, go a little bit about background, or directly get into the conversation or the questions you have. Let me know.
Give us the 30,000-foot view of your background a little bit, because I gave them kind of a teaser, but I'd like you to kind of give us a quick
Sure. I'm originally from Armenia. I did my undergrad in UK, and then I got into Princeton to start my PhD. When I got into Princeton, the advisor who accepted me, he actually left Princeton as a professor and started his own self-driving car company in Bay Area. Pretty successful one. So I was very fortunate. I had to find another advisor, and I accidentally or incidentally got into Sebastian Seung's lab, which is he's one of the leading scientists in neuroscience and leading this field called connectomics, which tries to reconstruct the brain and understand how it works in ideally and simulate as well. And the problem that we had there is that we had essentially traditional neuroscience, focused on single or several cells in brain, and you have also psychology, which works on the functional side of things. And this connectomics tries to bridge the gap between single cell to actually how the functional, how the brain works. And what we have been working there is that it's pretty exciting, is that we were taking a mouse brain, cutting into very, very thin slices, imaging each slice. It's a very high resolution, and then uploading this to a computer, and then or AWS cloud here, better to say. And then we are applying this deep learning pipeline or machine learning pipeline to go from these volumetric images to the reconstructions of or the connectivity of the neurons by segmenting or separating the neurons, and then finding these connections called synapses, and then bridging the graph so that later neuroscientists can actually do science on top. And the problem that we had is actually we were operating on a petabyte or 1,000 times terabyte scale level data, and applying this huge amount of computation really is very expensive. And our goal was to reduce the cost by 2 or 3 times by rethinking how the data should be stored on an object storage, how it should be streamed from the storage itself to the computing machines. Should we use CPUs and GPUs, and what kind of models to use? And those are kind of the insights that it early brought us to start the company and go into Y-Combinator and launch our first iteration or first version of the product, that we learned so many things out of it, and then run a couple of pivots, start working with early customers in multiple locations, in multiple fields, in legal tech, in arc tech, and also in medical imaging space. And we also open sourced our data management solution, which I'll get into details later. Pretty excited about it. And we are growing pretty fast, but still a very small startup based in Bay Area.
And that's, what a cool situation. And I hope people, especially if you're feeling like, wow, I don't know a lot about how data works or anything, I think this is going to be a very insightful conversation, because what people aren't understanding is that the data, and I love David actually explained this to me, I thought it was so cool, is that if you're trying to transfer beta bytes, which is 1,000 terabytes, right? Is that correct?
Yeah.
Yeah, 1,000 terabytes of data. I mean, can you imagine trying to transfer that over Dropbox even? How much time it would take you to send 1 MB? And there's companies that are developing so much data that they have to then interpret and use. And so that's what the machine learning aspect is, right? Is trying to interpret data quickly. But if it's having to dig through, it's like having a secretary digging through files super fast to be able to keep up with it. I mean, you couldn't physically take care of it. So I want to ask you, David, because you did explain this very well. How would you explain a use case for machine learning in somebody who has maybe an agency type model, how they could use machine learning to enhance their business?
So when you say agency type, well, what kind of exact use case do they
B2B
have?
services, so marketing of some sort is
Got it,
actually
got
a
it.
really good example.
So as you mentioned, actually, one of the problems you said is that, let's say if you have this petabyte scale data set moving from San Francisco to New York, it's better or cheaper to have a physical truck to plug into one data center, load the data and move it physically to New York rather than like transfer it over the network and internet. And that's the current state of the network infrastructure, but it's getting better as well. In terms of and the problems that we are trying to solve is the following. If you open your desktop, you see all these files cluttered there. Or when you let's say you want to send your friend 100 images using Messenger, like you just had a photo shoot and sending to them, it takes, you don't know why, like so long just to transfer 100 megabytes, which is like a pretty small amount of size here compared to gigabytes, terabytes, or petabyte scale data sets. So, and what we are thinking or towards is actually rethinking how you should structure the data, or how you should keep all those files and images, and actually we're saying that, hey, you should no longer treat them as files or as images as separate, like you have this PNG, different compressions, JPEG and whatever, like how to encode it and so on. So what we want to make sure it's very easy and simple to use and operate on top of large data sets. Now, if you, let's say, are a B2B company in EdTech or MarTech, and you are collecting a lot of the social media data, like a lot of images, you want to understand what is the next trending color for clothes. Let's just take an example. And you want to parse so many images from Google, Instagram, and I don't know if you have access to Facebook or not for those images, but in general, like all the public images that people post on, like they wear some clothes. And the problem you have is that you start to scrape all this data, store in a location, and you have all this mess. Like each of them have different kind of formats, call it agendas and meta information and so on. And what we are introducing is kind of a unified way or unified format for storing all this data. And instead of treating them as separate files, we treat them as so-called like tensors, which are like n-dimensional arrays. So instead of having like this million different files, each of them having this 512 by 512 by 3 samples, we treat them as a single like million by 512 by 512 like cube. Think of it. And we call them tensors. And you have like multiple these tensors that represent the nature of the data. And what it allows you to do is that in one click, you're away from training a model on top. A training model that can provide you insights. Okay, what is, like, can we run a prediction of forecast, like what will be the trend, or can we generate some features from this data to understand what are the trends moving forward, and how we can use it in the business to be able to generate business value. The biggest problem, actually, you mentioned, this is pretty good, is that generating business value from unstructured data is very expensive, and people usually don't do that. Like today, companies really nailed down the structured world where you have Excel sheet or this columnar databases or data, like just numbers and tables. It's very easy to go from this to and generate a business insight that can actually help you to improve your revenue. What people haven't yet figured out is like how I have, like, let's say, video security cameras that have million like streams of video that's coming every day, and how I can make money out of it, or like what was the business use case there. And it's very expensive today in terms of technology itself and infrastructure to run this. And what we are aiming for is that if we can make this processing much cheaper, the storage cheaper, given the hardware what we have today, we can actually enable more use cases in unstructured data processing that will bridge the gap and bring business value back to the business owners that they operate on.
I love that. And I mean, you look at it in the terms of marketing, as you're saying, is it creates all of these opportunities for you to be able to predict what you need to sell. And that's such a big, especially for our friends here in the e-commerce space, right? If you have an e-commerce agency, that's huge. I mean, being able to know who wants to buy what. I mean, huge. I'm sure that's what Amazon spends 99% of their time doing, is trying to figure that out. Is to mine that data. That's a client you've got to land, David. Managing their data would be a
using their cloud
business.
resources and letting them become a customer. That would be good.
I'll let you know. I'll connect you with Jeff Bezos. No big deal.
Sounds good.
Anyways, I love that, David. Well, and I want to ask you kind of some questions more about the way you've been growing your company as well, because I hope people have gained a really good look at how to use machine learning. And if you want more information on how to do that, you can go check these guys out. They have a podcast about it, first off, which, David, can you let us know where to find that as well?
Mm-hmm. So you can easily search in Spotify or Apple podcasts like called Humans in the Loop. And you have me and Mikhail talking with different guests who actually are building businesses based on machine learning. One of the potential guests we had is like Ava, who generates music. We have another guest, Anna, who is like applying biomedical image processing to help cure rare diseases. And we have architect use cases as well, agricultural technology. And essentially our goal is, instead of like putting this into hype and then saying how AI is going to take over the world, actually to drill down on the specific use cases that people currently apply machine learning and how it benefits people, and starting from farmers to doctors, patients, and so on. So love to have everyone there.
Love this. This would be a great agency to partner with you guys as well if you have clients in those sectors, because this will make you look 10 times better. So go check those guys out. So the podcast is called Humans in the Loop, which ties in really well to their website name, which is activeloop.ai. So make sure you go check that out. But so I want to ask you a few questions, David, about how you've been growing, especially because you went the VC route, right? And finding so Y-Combinator, if people aren't familiar with that, it is an incubator. They invest in their companies and they help these. I think you have to be under 24, right? In order to be.
No, there's no age restrictions.
There's no age restrictions. What was the one, Peter? The Thiel Fellowship. That's the one that Peter Thiel did, right? Mm-hmm. But anyways, Y-Combinator, right? So there's no age group, no age restrictions. But once you get accepted to that, it's a group of investors who really have a great network, but they help you to grow these tech companies and to scale them. So we've already heard the story of how you were able to get in after your fourth try, but I want to ask you this: is how did you find customers once you had that backing? What have you guys done to be able to actually scale your business?
Mm-hmm. So we initially, the number one thing that we started doing is like pinging all the Y-Combinator X companies and saying, hey, like, let's have a chat and see what kind of problems you have. And actually, very surprisingly, a lot of them replied. And we had personal meetings, coffee chats before COVID era, that we were learning about their business insights and the problems they are facing today. And initially, our initial idea was that, hey, we can actually run the computations for you. And we haven't bothered about the data. And like one of the actually ex-directors of Y-Combinator, who is now a CEO of Applied Intuition, sit down with us, asked his CTO to come join us as well. And he started asking a bunch of grilling us on technical questions and how you build this initial infrastructure for this computer processing. And the thing is, like, he came to the conclusion very quickly. It's like, hey guys, these guys that have thought a lot of stuff and there is some promise there, but they haven't thought about the data and how to move this large data to this infrastructure. So this kind of the first insight that brought us, hey, actually we are, and the whole industry, that what we feel is like they are focused on this computation aspect, and people really don't want to work on the data and like the data storage. And you have this data scientists or machine learning engineers that really want to do machine learning, but if you ask them, they actually spend their 80% of the time on data janitor work, like cleaning, wrangling, versioning, and making sure the data is correct. Because actually machine learning, you give what kind of input you give to the model, that's what the model you get as an output. So working with this, getting a lot of rejections, getting a lot of feedback from the community of Y-Combinator, and it's helped us to shape the direction we are moving forward. And the first customer that we landed actually came through the investor. So like the first POC that we run into, and this legal tech company that they had 18 million text documents, the problem was to train a model that can go from text to numbers so that they can do very efficient search. It wasn't just an introduction over the VCs. We had a personal network as well for the customers before getting into Y-Combinator, but those were like more like VCs have kind of bird's eye view what you are doing, and they also can easily connect to their network of the other portfolio companies if your target customer is in their field. So yeah, that's the benefits. Of course, it has a lot of like downside as well, but given our background, coming from being a PhD student from Princeton and not knowing the business and all this like startup ecosystem, like getting into YC, getting all this advice from our partners, the environment here, and investors, actually they also care about you and they want you to make it successful, not only because of the return money, but also their time is also very important for them. So they want to make sure they enjoy the whole process as well, and they are really helpful in very tough, and we had a lot of tough situations in the company as well. So yeah, that's kind of the breakdown. I don't know if I've answered your question
You
exactly.
have, absolutely. And what's funny is we all know it, right? I mean, there's 500 war stories we could tell about the difficulties of running a company, especially a fast-paced company in the tech world. So I am kind of curious, as you guys are growing this now, you're expanding into new markets. I mean, you recently said, so the newest market is entertainment is where you've been heading into. Is that correct?
Yeah, so we basically see a lot of interest in people starting to analyze a lot of videos that they have already stored in their archives, and to get more insights, let's say what they should do next, or there's like sport analytics, so many bunch of use cases in aerial imaging, in architect, and biomedical imaging, that people, instead of having this high-pitched models like, oh, AI, or like self-driving cars, we actually don't have yet self-driving cars deployed into the system. Like actually people start to use this in very important aspects of the life, the human life and human development, that I feel like this will be the kind of next 5 or 10 years that actually going to make difference, instead of just focusing on self-driving cars.
Love that. See, and it's what's fun about what you guys are doing. This is what sparked my interest so much, is, as you said, there's this huge rise in tech companies and it keeps growing. And a lot of people keep thinking that quote unquote bubble's going to burst, but it's just because it's the new generation of company. So they keep growing, and you identified a problem that every single one of them has that they haven't thought about. It's, how am I moving this data? And so they're spending ridiculous amounts of money moving the data. And you said, well, let's just make it cheaper for them. Let's create a simpler, faster, and a less expensive way to do it. And so I want everybody who's been listening to this interview to pay attention to that. I mean, look at the way that they said, it's not a sexy business model, and not to be a jerk, right? So it's not
nobody wants to do this. Like it's right. Like the dirtiest job you can do in machine learning end-to-end platforms.
It's literally like the garbage man of it, right? Like nobody wants to be the garbage man, but the garbage man makes more money than you half the time, right?
and mafia runs the garbage business, so you get the output.
Exactly. I love that. And so for you, especially where you've been working with a lot of these big tech companies, how have you been identifying these new markets to enter into?
I think that's a good question as well. What we are looking for is that, first of all, if this market is with our size, meaning that we are a small startup, is like, and we should target market sizes that are adjacent, or that we can actually reach out. And then the second point is that, can you ask this fundamental question? If, let's say, there is a depression or the bubble bursts, are those companies going to survive, or are they going to go through the wave as well? And what boils down is, what are they doing? Is it essential for their customers? And is it essential to the whole like value chain you have there? I feel like if we don't have self-driving cars tomorrow, even like our next 5 years, nothing that difficult will happen to us. But if we let's say there's a short supply in terms of food, or like with, let's say, cancer detection, if there's like a 5% or 1% improvement can be done. I mean, you can also save a lot of lives with having self-driving cars operated all over the place. That's true fact, but I feel like you can do so much in these hidden corners in the business world and the impact world. Less about money, but actually on impact side of the things, and those really matter, but they're undercover. Nobody's talking about them, or nobody really cares about them. And we had the same problem as well when I was at Princeton and I was working in this neuroscience lab, and we were analyzing a lot of brain images and biomedical images. And I was talking to my fellow friends who are actually in computer vision lab, that I was initially supposed to go there, but I ended up in neuroscience. And they were working with these cool image data sets with a lot of like images, cars, trees, and so on. And when we have to go and publish a paper, the reviewers, they already like have a bias or risk, that kind of how to say, like they're already kind of want to see, oh, cool, nice pictures. But what really matters is that can we actually save a life with this biomedical image processing, and they pay less attention to that. So that's the kind of the moral, is that we have this natural interest in glorious and fluffy stuff, but there are a lot of like actual problems that people underestimate how important they are, and which actually matters. And that's what you fundamentally you should ask. I have a very good friend. He's in the logistics, like a totally different space, and he's asking this fundamental question, actually similar to the data transfer, but actually on a logistic level, like transferring any, like, can you ask why, for example, Apple should, like, you are eating an apple, it should come to you, like, I don't know, like 3,000 or 4,000 miles away. This apple has been like cropped. Like, is this efficient today? Is this the way how it should be done, or there are some other better ways of solving this transportation or logistics problem to make it optimized? So yeah, I think the question is, like, if you can answer this why question deeply, why do the humanity need this? Whatever happens, like there's depression, like, I don't know, asteroid comes onto us, and if you can pick the best like market near it to these questions that are essential, that can help you to like build a business on top.
I love that. That was some real words of wisdom there, and I hope people will pay attention to that, because it's all about finding that problem. Find a real existing problem that nobody else is trying to change, right? And everybody thinks about their use cases, right? Well, I'm on social media, so maybe I could build a business around social media, right? But think about it, where there are big companies with they have deep pockets, lots of money available to you, but they have big problems that they don't know how to solve, or they're spending billions to try and solve that maybe you could solve for much cheaper. So I really appreciate what you guys have been doing over there at Activeloop, David. So once again, everybody, go check out their website at activeloop.ai. On top of that, David, though, just to kind of wrap up this interview, could you give us one final parting piece of guidance for our audience?
Yeah, actually, you mentioned this. I have done this mistake so many times. You're saying, like, you have the social media, that's in marketing, in technology. Oh, we figured out this technology, how we can connect to these businesses, or how we can connect to this problem. I think whatever you do, like, you should really think about problem first approach, and also less of, and you mentioned about businesses and they have a lot of cash, and like, so think where you can create most value, which could be compensated by the cash. And the third one is, like, pick a problem that actually you deeply care. If you don't deeply care about like this data cleaning stuff or garbage, like making sure it's very clean, then don't do that. Like, you should really pick some kind of a problem that, like, there's some internal motivation that even if everything is failing, you wake up and still, like, yeah, I'm going to do this no matter what. So that will help you to survive, like increase the chance of survival, because anyway, building a startup is like a large chance and large wins kind of game, I would say. But that's why you should find a meaning that you're going to spend most of your life onto this, and the most precious time that you have.